Good afternoon, all of you. Example number 3. A thin homogeneous wire of length 350 millimeters is bent into the shape of letter C having height 150 millimeters as shown. The bent is suspended from the end A. Determine the angle made by the portion AB with respect to the horizontal. See, the total length of the wire is given 350 millimeters and it is bent into the shape of a letter C of height 150. So can you tell me what are the dimensions? What is the length of portion AB and CD?
100.
100. Right. 100 millimeters. Now this letter C is symmetrical about horizontal axis. Right? Suppose if you consider this symmetrical axis as X and this is Y, we know that the centroid will be located on the symmetrical axis, centroid or center of gravity. Its distance from Y axis is X bar, right? Also, we know that when a body is suspended from any point, the center of gravity of that body will be located on the vertical line passing through point of suspension. Here, this letter C is suspended from point A. And if you draw a vertical line through A, the center of gravity should lie on that vertical line. Suppose it is suspended from point A. This will be the shape position of letter C. The A, B, C, D. And you are asked to find out the angle made by portion AB with the horizontal. Let us say theta. So we know the symmetrical axis of this letter C, and also we know that the center of gravity of this bend will be located on the vertical line passing through the point of suspension. That means the intersection point of these two lines is the exact position of center of gravity. Right? So write down the statement. When a body is suspended freely, from any point, the center of gravity of that body will be located on the vertical line passing through the point of suspension. So see this figure. We know that this distance of center of gravity from BC is X bar. Let us say this angle is alpha. Then how much is this side? What is the length of this portion? Total AB, we are having 100 minus X bar. So it is 100 minus X bar. Can you tell me what is this dimension? This distance? Yes.
75.
Yes, total 150, half of that, 75. Now from this right angle triangle, you can write tan alpha is equal to opposite side, that is 75, upon adjacent side, 100 minus x bar. From this you can calculate alpha, and you are asked to find out the angle made by AD with horizontal. So theta is equal to 90 minus alpha. That gives you the required answer. So simply, first you have to calculate x bar, right? For that I will divide this belt into three parts. Line AB, say one part, line BC, and the line CD. So we can write x bar is equal to summation Lx upon summation L. That is L1 x1 plus L2 x2 plus L3 x3 upon L1 plus L2 plus L3. Now what is L1? Length of portion AB, 100. X1, midpoint is the centroid. Its distance from y-axis, 50. Plus L2, length of portion BC, 150. And what is X2? For BC, midpoint is the centroid. It is located on y-axis, so X is 0. Plus L3, length of CD, 100. Distance of centroid, 50. Upon L1 plus L2 plus L3. That is the total length, 350. So calculate x bar, then alpha, and finally theta.
So can you explain the whole thing once again, summarize?
This letter C is symmetrical above horizontal axis, right? I am taking that axis as x. We know that the centroid or center of gravity will be located on the symmetrical axis, right? So for letter C, we know one axis of symmetry. When it is suspended from point A, when a body is suspended from any point, the center of gravity of that body will be located on the vertical line passing through the point of suspension, and that vertical line can be called as axis of symmetry. So when the letter C is suspended from point A, we know that this vertical line is one axis of symmetry. Already we know another axis of symmetry. So the intersection point will define the exact position of center of gravity, right? So the distance of the center of gravity from y-axis is x bar. See, from the geometry over here, you know this total length of AB as 100, and this is x bar. So this remaining distance is 100 minus x bar. I am considering this right angled triangle. Let us say A, G, and E. So AE as 100 minus x bar, whereas EG is nothing but 75 because it is symmetrical about horizontal axis, and half of that, it is 75. So from this right angle triangle, writing tan alpha is equal to opposite side 75 upon adjacent side 100 minus x bar. So to find out alpha, you must know x bar. So that x bar I am finding using this formula. Summation nx upon summation n, dividing this belt into three parts. So for L1, that is length of AB is 100, x1 means distance of centroid of line AB from y-axis. So the midpoint, no? So it is 50. Length of L2, Here L2 is portion BC. Length is 150 and its midpoint in the centroid. That centroid is located on y-axis. Therefore, its distance from y-axis, that is x2, will be 0. Similarly, L3 is 100. X3 means distance of centroid of L3 from y-axis, that is 50. Upon L1 plus L2 plus L3, total length of the wire 350.
Sir, how
Sir,
AC
theta
is
is
75?
61.
Yes.
So the answer is theta is equal to 43.61.
What is X bar? 28.57. X bar is 28.57. And theta is 43.6. 43.6. Now the next example. A slender homogeneous wire is bent into a shape shown in figure and is suspended from point A. Find the angle made by portion AB with the horizontal. So this bent is suspended from point A. So it is having length of portion AB as R and radius of this circle is given R. But it is not a complete circle. Now say, suppose if it is suspended from point A and if this portion BE is there, it is a complete circle, for example, then this bend is symmetrical about this vertical axis. So center of gravity will be located on the symmetrical axis, right? But now you have removed this portion BE, then the center of gravity will shift towards left or right. The center of gravity of the bend will shift towards left. Away from the deduction, right? Say this is the position of center of gravity. Is it clear? Now, also we know that when a body is suspended from any point, the center of gravity of that body will be located on the vertical line passing through point of suspension. Means this G should lie on the vertical line passing through A. That means this entire bend will swing towards right so that this G will come exactly below A. Understood? Suppose when you suspend it from point A, you will find that this will be the position of the bend. And when you draw a vertical line passing through point of suspension, the center of gravity should lie on the vertical line passing through this point A. So we have this as A, B, C, D, E. Have you understood this? So it will swing towards right, so that this G will lie on the vertical line passing through A. Means it exactly comes below point A. So A is lying below point A on the vertical line. And you are asked to find out the angle made by portion AB with the horizontal, say theta. So you have to find out this theta. Now see this figure. with reference to the center of the circle. I am taking this as x-axis and y-axis. So the distance of center of gravity from y-axis is x bar. The distance from x-axis is y bar. So with respect to point O, you are having x bar and y bar, right? Now you tell me, how much is this distance? Distance of vertical distance of G from A.
क्लास होने के पहले देते नहीं है ना क्लास चालू खाना बना के यार.
Yes, distance between A and G, vertical distance. We know that it is given AB as R and the radius is also R. So from A to O, it is 2R minus y bar. So it is 2R minus y bar. Now considering this right angle triangle A, G and F, we have AF is 2R minus y bar and GF is nothing but x bar. So let us say this angle is alpha. From right angle triangle A, G, F, we can write tan alpha is equal to opposite side, that is x bar, upon adjacent side 2R minus y bar. So knowing x bar and y bar, you can calculate alpha and hence theta. Theta is 90 minus alpha. Have you understood the geometry? So for the given belt, first you have to find out x bar and y bar in terms of r. And putting the values over here, calculate alpha and hence theta.
Sir, please repeat geometry, sir.
See, I am taking the center of the circle as the reference point. With respect to point O, I am taking this as x-axis and y-axis. The centroid, the position of centroid is G, having coordinate x bar and y bar. We know that the center of gravity will be located on the left hand side only because this portion B is removed. So center of gravity will be on left hand side, right? Now, that belt is suspended from point A. So when a body is suspended from any point, the center of gravity of this belt will be located on this vertical line. So G is located on this vertical line, having coordinates with respect to this point O, x bar, y bar. Understood? So considering this right angular triangle GFA, this is the right angle triangle. Saying this angle as alpha. The opposite side for alpha it is x bar, that is GF. And adjacent side, that is AF, is nothing but from A to O, A to B, it is R, given in the figure, A to B is R. And the radius of this circle is given as R, so it is BO is R. So total distance is 2R minus OF. OF is nothing but y bar. So for this right angle triangle, we have x bar and 2R minus y bar as the sides of the triangle. So from that I am writing tan alpha is equal to opposite side to adjacent side, then alpha and hence theta. Now the point is to find out x bar and y bar.
Sir,
So,
the centroid should be on the lower half of the ring, sir.
No, because
Left side but on the lower side, sir.
See, for this circle, see here, for this complete circle, O is the center of gravity. So we are removing this. Therefore, it is shifting away from the reduction towards left. Now, we are adding AB. AB is added, no? Then the center of gravity will shift towards the addition. Therefore,
Excuse me, sir,
yes.
but it is not, the portion of the circle is not removed uniformly. So I think it makes intuitive sense that it would lie on the angle bisector of this 270-degree angle.
Yes, but this addition is there, na AB.
Yes, after that AB, then it will come upwards, but
Right. Suppose if there is no AB, you have only these 3/4 of the circle, then the center of gravity will be located as you said on this line here. So as we are adding AB, it will be shifted towards the addition. Right? Now, to find out X bar and Y bar, I am dividing this bent into 3 parts. One is portion AB, second is quarter circular arc BC, third is semicircular arc CDE. Right? Now you tell me these values. L1 means length of AB is R. X1. What is X1? Distance of centroid of AB from y-axis. So midpoint is the centroid. So its distance from y-axis is 0.
0.
Y1. Distance of centroid of line AB from x-axis. So this is Y1. From O to B, R radius, and from B to this point, right? R plus R by 2. 3R by 2. L2, length of this quarter circular arc. Yes, pi R by 2. Right? X2. What is the formula for quarter circular arc? Location of centroid. X is equal to distance of centroid is located at 2R by pi. Right? But it is on the left hand side. So it is minus 2R by pi. Y2, distance of centroid from x-axis. Again it is 2R by pi. Right? L3, length of semicircular arc. It is pi R. X3. This semicircular arc is symmetrical about vertical axis. Centroid will be located on the symmetrical axis. Its distance from base of the semicircle is given as 2R by pi. So here X3 means distance of centroid from y-axis. Being it is located on y-axis, X3 is 0. And the Y3, distance of centroid from x-axis. It is below x-axis, minus 2R by pi. So minus 2R by pi. So then X bar is equal to L1x1 plus L2x2 plus L3x3 upon L1 plus L2 plus L3. Similarly, and Y bar. L1y1 plus L2y2 plus L3y3 upon L1 plus L2 plus L3. So we are going to get x bar y bar in terms of R.
Sir, he is asking about x2 and y2.
X2 and y2. Okay. Now say. You have this as x-axis, this is y-axis. So x2 and y2 are for this quarter circular arc, that is BC. So for this quarter circular arc, the centroid or center of gravity will be located at a distance, say x bar from y-axis, y bar from x-axis, given by x bar is equal to y bar is equal to 2r by pi. Refer formulas. Formulas for quarter circular arc. In the formula it was given in the first quadrant. Therefore, x bar and y bar are positive. In this particular figure, this quarter circular arc is in the second quadrant. So x bar is negative, y bar is positive. That means here x2 is taken as minus 2r by pi, y2 is 2r by pi.
Sir, is alpha is equals to 5.23.
No, first you tell me what are the values of x bar and y bar.
Sir, x bar is pi r by 2
Okay.
and y bar is half r square.
So here x bar I have got 0.175 r and y bar is 0.087 r. Then I have alpha as 5.23 and theta 84.77.
Sir, x bar would be minus
What is minus?
x bar.
Yes, of course. It has to be minus. It is on the left hand side. Minus 0.175 r. But here, when finding this alpha, don't put minus value here. So from the geometry of this, we are saying it is x bar upon 2r minus y bar to take x bar value.
Sir, is it possible to consider the entire arc as one part and use that r sine alpha upon sine alpha formula?
It is possible, but it is a difficult process. You have to consider this entire thing as a circular arc. Then it is symmetrical about this line. Centroid will be located on the symmetrical axis. Its distance from center of the circle is x bar. That is r sine alpha upon alpha. Right? And then you have to calculate by taking the moment of this arc about x-axis. So it is length of the arc into distance of centroid from x-axis. So you have to find out this distance.
Sir, can't we take the components about the x and y axis?
You can take. You can solve by taking this one as circular arc also. No worries. This one now, example number 5. A homogeneous wire ABCD is bent as shown in figure and is attached to a point HC. Determine the length L for which there are two parts. Part 1, portion BCD is horizontal, and part 2, portion AB is horizontal. So the first part, portion BCD is horizontal. It is suspended from point C. So you have to find out the length of portion CD for portion BCD is horizontal. There are two methods of solving this. One is conventional or traditional method. What is that? It is given that is suspended from point C. We know that when a body is suspended from any point, the center of gravity of that body will be located on the vertical line passing through the point of suspension. Now, with respect to point C, suppose if you take this as horizontal axis, x-axis, and this is y-axis, you can say that center of gravity of this belt is located on y-axis. Therefore, x bar is 0. So dividing this belt into different parts, like say portion BCD and portion AB, you find out x bar equal to 0, calculate L. Right? That is one method. Then second is logical method. See, when a body is suspended freely from any point, the center of gravity is located on that body, on that line, vertical line, passing through the point of suspension, and that line can be called as an axis of symmetry. Right? Because we know that the center of gravity is always located on the axis of symmetry. We know that it is located on this vertical line. Therefore, I am calling that line as axis of symmetry. From the definition of axis of symmetry, what is the definition? It is the line which divides the body into two parts such that the moments of those parts are equal and opposite on both sides. So this line is dividing this figure into two parts, left hand side and right hand side. So on left hand side, we have line BC and line AB. So the sum of the moments of these two lines about this vertical axis is equal to the moment of line CD about the vertical axis. Are you getting my point? So simply I am equating the moments of these line segments on both sides of the axis of symmetry. Right? So length of BC is given 200 millimeters. So you can find out the length AB from this right angle triangle. CA is given 150. So AB is equal to square root of 200 square plus 150 square. That is 250 millimeters. Right? So write down one statement. Equating moments of line segments about the vertical line passing through point C. Passing through point C on both sides. So here on left hand side, what is length of BC? 200. I am taking moment of line BC. Moment of line is equal to length into distance of centroid of that line. So length is 200 into distance of centroid of line BC from y-axis, from this vertical axis is, yes,
100.
100 plus moment of line AB. Length of line AB is 250 distance of centroid of line AB from this vertical axis. Midpoint in the centroid. See, in a right angle triangle, for this ABC, AB is the hypotenuse, right? So if you draw a vertical line passing through the midpoint of hypotenuse, that vertical line will divide this side into two equal parts. Similarly, if you draw a horizontal line, that line will divide AC into two equal parts. But we want distance of centroid from vertical axis. That is nothing but 100.
100.
200 by 2. So it is 100. Is equal to, on right hand side, length of line CB is L into distance of centroid from
L by 2.
vertical axis, L by 2. Solving this equation, we can get L.
So 300 root 6.
L is equal to 300, right? Now draw figure for second part.
Find alpha.
Yeah, you need to find alpha also. So second part is portion AB is horizontal. Portion AB is horizontal. Again, it is suspended from point C. We have this as A, B, C, D. BC 200 millimeters, CD is L, AB is 250. Let us say this angle is alpha. And it is given that this is 100. Sorry, 150. So we have alpha is equal to tan inverse 150 by 200. That gives you alpha is equal to 36.87. We need that alpha. Okay, now it is suspended from point C. We know that when a body is suspended from any point, the center of gravity of that body will be located on the vertical line passing through point of suspension. Hence, that vertical line can be called as axis of symmetry. Therefore, we can equate the moments of line segments on both sides of axis of symmetry. Left hand side, we have line BC and line AB. Right hand side, we have line CD. So taking moments about the vertical line passing through C and equating on both sides. Tell me now, what is the moment of line BC? Moment of line BC about vertical line. Length is 200. Distance of centroid of line BC from the vertical axis.
Because of
Can you tell me this? Length of this portion? You have this as 200, it is alpha.
80.
So adjacent side is 200 cos alpha, right?
80.
Now from this red angle
Not
triangle,
200. It should be
BC
100.
is the midpoint. If you draw a vertical line to the midpoint of hypotenuse, that will divide this side into two equal parts. So that is 200 cos alpha divided by 2. That is our x distance. So it is 100 cos alpha, 36.87. Is it clear? So this total is 200 cos alpha, half of that, 100 cos alpha. Now moment of line AB, length of line AB is 250 into distance of centroid of line AB from vertical axis. So we know midpoint is the centroid, its distance from y-axis. Being in the midpoint of AB, AB is 250, so you have this as 125. Right? This is 125. We want this distance. Anybody?
Sir, it's 35.
No, you tell me in terms of expression and then value. See, this 200 cos alpha, this total distance, minus 125 will be the distance, right? 200 cos alpha minus 125. So it is 200 cos 36.87 minus 125. So we have taken moments of these two lines is equal to moment of line CD, length is L, into distance of centroid from the vertical axis. So we have this as L by 2 alpha. So it is L by 2 cos alpha. L by 2 cos 36.87. Solving this equation, we will get L. Yes.
so please explain that 200 into 100 cross alpha, that distance 100 cos alpha.
200 into 100 cos alpha. So we have this A, B, C. Now BC is given 200 and this is angle alpha. Now you tell me how much is this distance?
200 cos alpha.
200 cos alpha. Now you consider this right angle triangle. This right angle triangle. Hypotenuse is 200. You have this as alpha. So midpoint, if you draw a vertical line to the midpoint of hypotenuse, that will divide this side into two parts. That is 200 cos alpha divided by 2. That means 100 cos alpha. So we are taking moment of line BC above this vertical line. Moment is equal to length is 200 into distance of centroid. So this perpendicular distance we want, na? This distance. That is nothing but 100 cos alpha. Half of 200 cos
Sir,
alpha.
what?
200 into 100 cos.
Can you explain for line AB?
Line AB. You have this A, B, C. And the vertical line. So what is the length of AB? 250, right? So midpoint is the centroid. So you have this distance as 125, right? Total 250 of 125. Now by taking moment of this line AB, moment is equal to length of the line AB into distance of centroid from this vertical axis. So we want to calculate this distance, right? So here length is 250 into, to calculate this distance, we know this as 200 cos alpha. So this is alpha, this is 200, right? Adjacent side 200 cos alpha. This total minus 125 is the distance of centroid from vertical axis. So 200 cos alpha minus 125. Okay?
Sir, is it L is equal to 250.31?
L is 248.75.
Sir, I got 250.31. Is it okay?
Okay, it's okay, no problem. Okay, thank you. We'll see you in the next class.